Hey guys, welcome to Sopi Studio Umbiamas, conectando Aruba com o mundo via vídeo podcasting. Conectar conosco, compartilhar ideias e histórias para nos inspirar e para peconan abrir. Sopi Studio é plataforma de podcast na Aruba. Follow-nos riba Facebook, subscribe riba YouTube ou riba plataforma de podcast preferido. Escute o podcast preferido que hora e onde está. Sopi Studio, powered by Qredits. Botiu ideia? Qredits educava e prepara abo para vir um empresário exitoso. De business plan, guia personal e préstamo para negócio até com 100,000 florin. Bira bom mês donho com Qredits. Sopi. Passa na Sopi para o sop, salada, wrap ou flatbread e mais fresco. Com 7 localidades rond Aruba. Nós está cerca de Ibo. Sopi. SwingMasterz. Organizando events, conferences of weddings. Mister de luz, sound, staging, DJ, trussing of LED screen. SwingMasterz está claro para ser boa fiesta éxito. SwingMasterz. E agora, Sopi Studio é plataforma de podcast de Aruba, está apresentar.
And we were having technical issues.
Good morning if you just woke up, and good afternoon if you've been around. And we're going to have a nice talk about the cosmos.
The cosmos. Not the show. Not the show, the cosmos.
Is that a show?
That is a show.
By my good friend Neil deGrasse Tyson. Right? Well, he's one of the great speakers on educating the masses on
astronomy,
I guess astrophysics.
Yeah.
And I want to share that with my my viewers. I recently, not recently, I've had it for a while. Astrophysics for people in a hurry, and I'm now almost to the end.
Wow.
And it's sort of like a fast track manual for people to go through. I guess the consensus of what astrophysicists and astronomers and cosmologists. And it's very interesting, really. Where are you at with your? What are we going to share with our listeners today about? Let's start with you.
I mean, wait. We need to go through the formalities first.
Oh, sorry.
Yeah.
Yes,
so
thank you.
The sponsors, right? Subway, Eat Fresh. Such a good catchphrase, to be honest.
Oh God!
Like, I don't.
Good for you. Thanks to Subway, Eat Fresh.
Subway.
Yes, thank you.
Qredits. Not Qredits, Qredits.
Okay, Qredits.
And SwingMasterz.
And SwingMasterz to get all these amazing shows. And, let's give a compliment to the amazing design team, because I do feel we've gone forward with these amazing graphics. So kudos to the team that is run by our producer and our designers out there. And we're really digging it, and it's inspiring us to do better. And
Brief introductions before we continue on. My name is Jean-Luc. I'm a student at the University of Aruba, and I've had a interest in tech and games my entire life.
Yeah, Bruce Harms here, advocate of digitalization for positive impact in the community.
Very nice.
I'm keeping it alive. Every time a different one.
Yes.
And I obviously what I love about Tech Impact is where you and me can kind of have our passions, and we can discuss pretty much anything. And I grew up, to give a little bit of history, I actually owned a couple of telescopes. And I was almost to the point of more obsessed about the telescope, like people are obsessed about cars, than actually using it. Excuse me. I did use it. So I used to have something called a refracting telescope, which is basically a tube with two pieces of glass, right? And it's refracting the light for magnification. And I used to have a reflector. And my first ever project from multimedia school was called Scope Kids. And I actually designed a animation for education, how the light goes through the the machinery.
Quick thing. I think we are hearing ourselves currently on Facebook.
Oh, thank you for that. Here we go. Thank you.
Yeah, there we go.
There we go.
Sorry about that, viewers.
Yeah,
and
sorry about
listeners. I hope whatever you're going to cook is very, very interesting.
Yeah, so
Astronomy, astrophysics.
the first object I actually pointed my telescope at Arashi Beach was the Orion Belt.
Oh.
And I actually saw the little like milk. It looks a little bit milky. And I saw the Orion Cloud. And I used to have a little book called the Messier Sky Catalog. Right? And that's where my interest in astronomy started.
I've actually had a old friend of mine who also had a telescope, right? Shout out to Yvonne, right? And so the first object I've seen was like Jupiter. I could see the rings.
Yeah.
So that was fascinating.
So anybody out there, if you get you can get a pretty good telescope, because the most important part of a telescope is actually the eyepiece, right? Because a telescope is configured like a lens is from a DSLR. So a 50 millimeter and a 25 millimeter gives you different scopes, and planets are very well visible.
Yes, very bright.
And you'll see like a little. I saw Jupiter and the moons.
Oh wow!
The moons you see as stars, little tiny stars.
Little dots around them.
And one thing though, Aruba's so windy that when you point a telescope on a tripod, it will shake, So I've seen the planets from my telescope. And let's talk a little bit about what I want to share with you what I've been learning.
Go ahead.
So let me ask you this.
Tell me.
What is the most mysterious, interesting object in the sky that you know of? Or what's something that boggles your mind?
Two things.
There you go.
Yeah. Black holes. Of course. Right.
How can we say?
And neutron stars.
Neutron stars.
Yeah.
Oh man, you're gonna make me. And do you know from the top of your head what a neutron star is?
A neutron star is basically a hyper inconceivably condensed star that spins extremely rapidly.
That's been what?
That spins very, 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 very incomprehensibly fast, and it has like two geysers at the poles that shoot superheated and high energy particles.
And did you know that that's actually a indicator of a star's life?
Oh no!
The stars have different phases of their lifetimes.
That's near the end.
Yeah, that's the end result of a collapsed core of a massive supergiant, right? So, for example, let's talk about our sun. Our sun is a relatively young star, and our star is now it has a hydrogen core, and the hydrogen core it's basically a nuclear reactor, right?
Yeah.
And it's going to turn into
helium,
right? And then it's going to expand. So the end of it all is potentially the star just expanding and
consuming the planet.
But what's interesting to learn about that is that galaxies, they're let's call it, they have lifetimes as well. So if a star has a life and it will go dark, can a galaxy keep generating stars? And that's kind of the question, which, for example, are the questions that are being asked in the question, is the universe forever? And the short answer is no.
No.
And this is where...
short answer.
The short answer is that right now, it seems that if we want a cosmos to exist forever, there has to be a cycle.
Yeah.
And the cycle is actually, explosions that disperse material, and then through gravity, things come back together. So we're actually a solar system that exists at the edge of the Milky Way. that is the result of a highly violent event.
Lots of explosions.
And if I have to give it a timeline, I think our planet, we got to give it an age of approximately 5 billion.
4 or
years.
5 billion, yeah.
Yeah, approximately.
Yeah.
And anybody out there, like a good friend, Elton is going to be with us in the next show, because just so you guys know, there is so much to talk about.
Yes.
Regarding what we know as humanity of the observable universe. And this is the kind of lingo that I've been, I'm being taught by reading this book. But I want to talk about something called the local group.
The local group. Isn't that like the local neighborhood of galaxies?
Exactly. Yeah. So if I highly recommend for anybody that wants to kind of dive back into it, if you search for the famous pictures of the Hubble Space Telescope, there's this famous picture when they take a little part of the sky and they blow it up. And what's interesting, you're looking at the past and you see literally hundreds of millions other galaxies.
Yeah.
What they've discovered in this, let's call it decade, if I want to be safe, is that these are moving away so fast that if we go in a starship right now and we go at the speed of light, they're actually moving away faster than we can catch up to them.
Wow.
So it's sort of an event horizon at some point. And that's why they've coined the group that will not do that, the local group.
Yeah. That's the small little assembly that most likely won't get away from each other.
And so when I have this awesome picture of my wife at the beach, and I'm actually using it for a lot of things, but I took up sort of a long exposure shot with my Fuji, and I got a little bit of star trail, but I did get the Milky Way.
Very nice. Very
yeah,
cool.
very nice. So that's what they're saying is that if enough time goes by, which in universal cosmos terms is not a lot.
I mean, to us, it's unfathomable.
Unimaginable.
It's unimaginable. You can't. Yeah.
You will, if you would point the Hubble Space Telescope into the sky again, you won't see what we saw now. So we live in this special moment in the history of the cosmos as a small little local group.
Yeah, it's very interesting, right? Because if you go a few billion years earlier, everything's on fire, essentially, right? Superheated gas everywhere.
Yeah, exactly.
Right?
That's that. Yeah.
If you go a little bit further in that same, or a little more forward, then the universe would have been a lot more dark than it is right now. Everything would have been, or by our current understanding and guesses, everything would have been far away from our observable universe, and we would be only with our local group.
Yeah.
So we live in a very special time.
And I didn't even get to explaining it just yet. So the local group right now is considered the Andromeda Galaxy, and the Milky Way, us, and I think about 30 or 40 what they like to call microgalaxies that don't have trillions of stars. They have a couple of 100 million.
Oh.
Yeah, I don't know the exact number. Don't take it factually yet. But we have about 30 other clusters, 20. And interestingly, Andromeda Galaxy will fuse with the Milky Way. We know that. That's a fact. That's a mathematical fact.
Instead of growing smaller, it's growing bigger over the years that we've observed it.
Yeah. And, I want to add on another comment that I've heard people say that astronomy is a pseudoscience because it can only be seen through a lens, and that is absolutely false because it also gets checked by mathematics.
Yeah.
And
heavily.
for example, I think Neptune was discovered by applying a mathematical equation to an observation and predicted the existence of the planet before looking for it.
Wow.
And then they found it. Because there was a shift in color, and that means there was a gravitational pull happening. There was something affecting something else. And then through a mathematical prediction, they discovered it. Please research it. For those that are naysayers of astronomy as a pseudoscience, please, that's absolutely false. here at Tech Impact, we're all about being students of everything that any science really has to offer. From astronomy is observing big spaces, by the way.
Yeah.
And astrophysics is where they go into the micro world, and this is when things get really strange.
Yeah.
And
theory of the big and theory of the small don't like each other much, and we're working on that.
And a lot of people don't know this. And when I have like these conversations at a party or something, in this book, there's a chapter that talks about the periodical table of contents, right? The periodical. I mean, at ISA, I remember I had the periodical table of contents. I also had a book about all the molecules and the neutrons and the protons, right? So, what's interesting is that the building block of the universe, hydrogen. That's one proton, one neutron in the center, and an electron. And it's kind of let's call it very eloquent that everything, the massive amount of information that exists on our planet comes from basically collision and evolution of the atomic periodical table coming into existence. And if I'm going to quote Neil deGrasse Tyson, is that stars are the ovens where most of these molecules were created or generated. And if you watch the show Cosmos, there's actually a chapter about where they think gold is made.
Supernovas, essentially.
Well, in other words, the most violent events in the observable universe. So I wanted to share that with you. So the next one, of course, is helium. And the book is written like a story, and the book starts with like, 1 millionth of a second what happened, and then the universe was compressed into 1,000th of 1 millionth of a period of a text into something about 5 light years across.
Insane.
And just for those that are not familiar with these terminologies, a light year is a measure of distance where take a ray of light and track it for 5 years.
And then you have 5 light years.
And then whatever those kilometers are. So we're talking about, unfathomable amounts of distance, which is the beginning gauge of trying to imagine the size of the universe. When I say I like using the cosmos because we have to now correctly call the universe the observable universe.
Yes, because it's the only thing it's the only light that has reached us so far. Yeah.
But what a wonderful time to live in. Yeah. And, and I also want who do you know about as contributors to this type of knowledge?
Hawking.
Right. So Stephen Hawking is one of the most famous astrophysicists. He's more than just an astrophysicist, by the way. But of course, Einstein and Newton, but in modern times, which I would like to call the 20th century advocates, there's a very inspirational person that speaks so eloquently, which is Carl Sagan. For my generation, that was an important person. Well, actually, it's even a little bit before. But Carl Sagan had such an eloquent way, such a calm way to talk about the cosmos, because what I think most people that are engaged in this segment of science is we're trying to find answers, trying to find origins of everything.
Pretty much.
And what I'm getting to is this place of from cosmology to astrophysics to the theory of evolution through natural selection by mutation, and then trying to understand us. So what I want to do coming up soon is actually bring together these books and kind of share with everyone what I think is super interesting. And what I love about what's happening today is that we're learning new things. And I think I would like to take Tech Impact there and start bringing this news, because it's not normal news anymore. When amazing discoveries happen, it's not main news. I mean, now it's all about, whatever it's about.
Yeah.
It's not about, it's almost niche information now, don't you think?
Yeah, indeed.
I mean, what's the latest thing that we've learned about astronomy? I had to dive deep into these websites.
The only newest thing that I learned is that green stars are impossible.
Oh, yeah, you told me that last night or this morning.
Last night.
Yeah. And why is that impossible?
So, complicated maths, essentially, right?
Yeah.
And the light that we see is based on this graph, right?
Mm-hmm.
And you can only split it between red, green, and blue.
Right.
And if we try to make the green the most predominant color within that little spectrum, right?
Okay.
So that would be the observable light. You will still have pieces of blue and red. And what ends up happening is a white star instead.
Well, because the spectrums put together becomes white.
Yeah, exactly. You cannot get rid of enough. You cannot bend the graph in any way to get enough of the red and the blue. So you will never have a predominantly green. You can only have the greenest star we can get would be white.
Well, let's go through a little quiz. Let me quiz you.
Sure.
Let's have some fun with that. Let's see how far you are. So,
the viewers can join us.
well, you can join us. What is the biggest star we can observe?
Betelgeuse.
Yeah, good for you. Yeah, so I knew you would get that one. We're wrong. We are wrong.
It's not Betelgeuse?
Well, Betelgeuse is usually the 10th brightest star in the night sky after Rigel.
Uh-huh.
The second brightest is in the constellation of Orion.
But that's brightness. Brightness does not necessarily mean size.
Yeah, well, let's go through it. So, classified as a red supergiant of the spectral type M1-2, Betelgeuse is one of the largest stars visible to the naked eye.
Oh, naked eye.
Yeah,
Okay,
so
okay,
there we go.
okay,
There we
okay,
go.
okay.
And sometimes I'm getting pretty good at it. Mm-hmm. I can look up in the sky, and who doesn't? I mean, if you live on Aruba and you just came from the beach and you're having a couple of beers with your friends at Arashi Beach, and on the right day, you just look up and it's amazing. It's amazing.
Yeah.
And I'm always trying to find a planet, and intuitively, I feel that whatever is the brightest and a little bit off, and obviously Jupiter and
Venus,
and Saturn, they can be anywhere at any time.
Oh, yeah.
And just to give you guys a little, what do you call it? Pet peeve? Little trick, little hack, is that Venus and Mercury are going to be low at the sky. They'll never be high up.
Yeah.
Because they come before the solar system, and there's only a small window where they're going to be available. Right. So. Yeah. So Mercury, for example, that's a really tough one.
Oh.
Yeah. That'll be low.
I mean, it's tiny as well.
Well, it's tiny, but it's close. It's the closest. Excuse me. Venus is the closest?
Venus is the closest, yeah.
Oh, my God. Our solar system. I'm the third planet.
Mercury is number one.
Mercury's number one. Yeah, true. And it is small. But Venus is brighter.
Yeah, Venus is brighter. Yeah. Venus is usually the brightest.
Yeah, true. So let's go to another little tidbit. So they discovered a new... let's call it a celestial body. It's called Ceres. Well, it's not new.
Celestial body?
Yeah. Do you know how our solar system is a bit configured besides the planet?
Yeah, we have massive asteroid belts as
exactly,
well.
Yeah.
We have like in the middle somewhere, and then we also have one at the outside.
Yeah, and the outside is called the Oort Cloud.
Oh.
Yeah, and what's interesting about the Oort Cloud, I think it was discovered by a Dutch. Let me see, Ort Cloud. Let me look it up, people. Please bear with me. If it's not Dutch...
Oh, what was discovered in it?
Well, that basically the Oort Cloud is where our comets come from.
Yeah.
And it's a lot like the asteroid belt. It's a massive spherical held by the gravitational pull of the sun, full of stuff, and of course
Rocks.
a lot of water and
Ice
and
minerals.
whatever space is made of. But it's amazing how, and if you would put the distance in scale, really put the sun its size and the planets, it is very far apart. The models kind of lie to you a bit.
Yeah, no, it is.
Actually, there's a famous YouTube clip of someone that did it in the desert, that he put the whole solar system in scale, and it was crazy.
Yeah.
And that the sun has so much effect on everything around it, and it got organized, and this is what I think is so beautiful, really, to come out of the chaos. And we sort of have kind of a shield, really.
Oh yeah.
Right, that shields us from what would our solar system look like or be like if we didn't have the Oort Cloud. I think it would be more violent.
Yes. But then we also have to keep in mind the chances of us getting rogue planets or rogue asteroids coming into the area. So that's the main danger I could think of, right?
Yeah. And but I'm thinking like this. Within the ecosystem of the gravitational pull, they're getting pulled in and out.
Yeah.
And yeah, there's stuff that can happen. But what about all the other stuff out there?
There's
what
lot
about
of other stuff?
Exactly. So what about that space?
Because
when it comes after the Oort Cloud, then things get a bit dicey. Nobody has really a scale on what in modern times, because we're moving within the Milky Way.
Yeah.
What really is going on beyond the Oort Cloud? Because we've sent many, I guess, drones and satellites and whatnot. But we can't really go beyond the Oort Cloud, not realistically right now with the technology we hold.
No.
And another problem we have is that, for example, the Andromeda Galaxy, correct me if I'm wrong, I think it's about 52 light years away or something like that.
No idea.
That's pretty close.
It is very close, yeah.
In galactic scales.
In galactic scales, exactly. Yeah. I wanted to touch on something very briefly, right? Something I find very, very beautiful and poetic, even.
Sure.
Right? Correct me if I'm wrong, right? But iron, one of the first, more of the heavier elements, is made also within the depths of stars, right?
Everything, really.
Yeah. Okay. So that would quite literally mean that the very blood that runs through us, right, that gives us our life, as far as we understand, is quite literally stardust.
Yeah. That in the end, we are emerging tool-making apes that came out of one star explosion if you put enough time on it. And then inderdaad, that's and I'm gonna throw in something in there that's would align totally with Benedictus Spinoza as a philosopher in his God called the universe, as something to be reverent to, if that knowledge. And by the way, Christopher Hitchens gave a beautiful speech on challenging people to reobserve all this information and realize that we're walking miracles, really.
Yes.
And by the way, one of the discussions that are happening within the astrophysics community is that it is not set in stone, this reality. This reality, if you would reset, if we would press a button and do the Big Bang again, there's zero guarantees that all the laws and all the molecules will be here. That's kind of crazy.
Yeah. We don't even know why we're mostly matter and not antimatter.
Yeah, exactly. And they're figuring things out. I mean, when you read the first chapter of Astrophysics in a Hurry, there's things that pop in and out of existence.
Yes.
And these are, this is when you go deep into a neutron, deep into, I think it's alpha and gamma. I don't even want to go there. I'm not an expert.
Something that Hawking coined, Hawking radiation, and it's the reason why black holes over incomprehensible amounts of times, grow smaller.
Yeah, and I've heard these debates about existence and from something to nothing. In the theory is not nothing to something; it is a singularity to an expansion, and whatever that singularity is, that's an event horizon we cannot look beyond.
Yeah, that was just existence.
And that's where you get into, interesting ideas of maybe there were many other singularities. Maybe we were 5 next to each other, and even now, if you say multiverse, it's right in front of you, because we actually don't know at the edge of the observable universe if any of these laws apply.
Yeah.
Right.
Yeah.
And that's what I love about how Neil deGrasse brings it forward, is that, well, when we go into astrophysics, anything goes.
And quantum physics, the polar opposite.
That's where
brethren.
it's hard for consensus. So, yeah, and in the end, people, let's be students. Let's just keep going. Tech Impact wants to be at the edge of what we know all the time, right? In every single aspect. And I can't wait really to start covering, because Tech Impact will kind of motivate us to keep pushing and keep learning. Another great documentary is, I think it's called The Edge of What We Know, which is the story of the whole world, the whole telescope community coming together to take one picture. And through amazing computer technology
And
to map it together. And they literally took a picture of a black hole. That is an amazing story, and it actually parallels with 3 professors, with student professors that were working with Stephen Hawking on trying to figure out the paradox, which is a black hole. And do you know what the paradox is?
I don't know. Is being able to see something that technically doesn't have any material? Is that it?
The paradox, and I'm not sure if I'm gonna have it right, but how I understood it was that if a black hole consumes everything, it could not leave a signature behind. So if you look at the universe as information that exists, right? You cannot turn something to nothing without having some kind of, and they discovered, and here we go, they're calling it the hairs. And to not spoil anything, they theorized that if something goes through the black hole, that it will leave behind like the Roadrunner going through a wall kind of thing.
Oh, a trail, sort of.
It would leave, and it seems that that's been discovered, which gives them a little bit more knowledge about the purpose of a black hole and what its function is within, the observable universe and how things work. And I want to get now to my favorite mysterious object.
Go ahead.
Quasar.
Quasars.
Yeah, quasars are an interesting celestial object. That's actually many celestial objects all put into one. So it's basically a hyper galaxy with many stars within a black hole that is just turning, and it's an enormous, highly powerful existing event. And we don't know much about them, except that that's where a lot of interesting things are happening, right? And of course, everybody thinks that within one galaxy, there's at least one black hole driving the whirlwind, right? And what was interesting from going back to Christopher Hitchens' speech is that he knows of one astrophysicist that his wish, that if he would have to go, he would like to go into a black hole so he can at least see it before he's gone. Yeah. And in theory, you could see time itself, right? That's what they say. So if the time-space continuum, right? is something. If time is a variable, because that's another discussion. By the way,
Yeah.
you could see the future and the past in theory.
In the black hole, because
in the black hole.
it's intense.
But obviously, coming within range, you'll be obliterated. Or
spaghettification.
did you know that when I was a kid, the Disney Channel had a movie. I think it was called The Black Hole. And it was a story of these robots. I loved that movie. But if I would look at it now, it would probably look a bit silly.
I think the talking about like a movie with a black hole, Interstellar, would be amazing.
Interstellar, it's a movie that gets me going, so I can't watch it all the time. It's so mind-boggling.
Oh yeah.
Right?
It breaks my head.
It breaks my head too.
Comprehending that, man.
I'm doing a little research.
So, but quasars are not necessarily the black hole itself. The quasar is a result of the intense,
there's so much going
energy
on.
mass and like materials spinning, and then eventually either going in and out, or just going out and then this laser essentially.
Yeah. You can literally see, vortexes and it's but it's not one star. It's a massive. Oh, there we go. There you. Thank you, producer. Look at that. It's nuts. It's absolutely nuts.
Aren't those quasars millions of light years?
Yeah, it's an enormous object. And Disney movie Black Hole, let me look for it. So, we've been obsessed about the sky forever, and that's what I think is really cool. I think
forever is a very.
I think it's in our nature to.
Maybe.
It's called The Black Hole. Yeah, that's what the movie is called.
On Disney?
Yeah, it's called The Black Hole. And I just remember there were two robots. And one was a little bit clunky, and it's a story. It's basically a little bit of Star Warsy epic story of escape, because they're gonna go into the black hole. They need to escape the gravitational force. So that's the kind of the education you get, But it's a 1979 film. The Black Hole is an American science fiction film directed by Gary Nelson, and it's a Walt Disney production.
I think another example, right, of astrophysics and astronomy, like proving each other, right, without looking at the same things, would be the relatively recent confirmation and discovery of gravitational waves that Einstein predicted.
Oh, yeah. Oh, but we're going to do a show on that one. And I'm going to finish the book. There's many interesting other tidbits of information. Neil deGrasse Tyson talks about the empty space, and that within the empty space there's a lot of information. It gets really hot, and he talks about supercharged particles. I mean, the cosmos is a crazy place, and I'm starting to realize that the whole solar system is sort of a cocoon for us.
Yeah, a protective egg.
A protective region.
Yeah.
Within, the Earth at 5 billion, offset from the ape 7 million. Homo erectus is there.
A few thousand.
No, at millions actually. And we about modern Homo sapien.
Homo sapien?
Yeah, I need to check that out, but it is such a blink of an eye compared to what we can observe and mathematically confirm about the age of the Milky Way, right? It's insane to think, could we even attempt to exist that long? And can we even rival the Jurassic period as just being here and staying here? Right?
Millions of years.
Well, it's looking a bit dire if you put it in those terms, right?
Yeah.
Like, are we gonna be around? If you tie in that everything that's ever lived on this earth, most of it has gone extinct. And I think answers to these questions will come from all these fields coming together. And hopefully, here's my message, listeners, from Tech Impact might even bring us together. And this ridiculous, idiotic war is an example, should be seen as an example of how far we still need to go.
It wasn't sounding as crispy.
Okay.
Yeah.
Is an extreme example of how far still we need to go as a species.
Sadly.
And sadly, yeah. And I hope that you'll be like us, the never-ending student. I want to be learning about this stuff until I can't learn about it no more. Right?
Wow.
How about you?
I hope whatever you were cooking or doing is finished and was great, or is going to be great.
And
see you next week, Stardust.
See you next week, Stardust. And by the way, a little bit of a passion. Next week we have F1. We'll be talking about the technologies. And we're going to bring some more better minds in astronomy than us, maybe, which we think is absolutely welcome.
Yes.
But F1 will be talking a little bit more, not only about the car, but what we've seen as an integrated total technological apex to create this platform, and the way they do the shows and the seconds. I mean, people are driving and they're losing by 1/100th of a second.
Wow.
And how this is measured and all the data they're using, and they're using virtual games to train the tracks. And I've started to realize it's an interesting subject for our show. So
all right.
With that, we'll see you guys next week. And Jeff?